Colin Brown.
I'm Mason Cipollini
This is Lab 10, Semiconductor Light Sources.
for OPTI 380 under TA Lab New Yen.
For part A of this lab, we looked at the dimensions and properties of different light sources. This started with using the microscope to measure each of the three devices given. To do this, we placed a clear ruler under the microscope and took a measurement of the pixels from one marking to another to get a baseline reference. From there, we placed each device at low drive current and marked measurements wherever we saw was important through the software. Then, we converted many of these measurements into millimeters using our initial ruler value. Once we had these values recorded, we went to the optical spectrum analyzer to record plots at the different drive currents for a laser diode. This involved using various output powers for the laser until we were able to find respectable modes. Finally, we used this emission spectrometer with the LED and recorded the peak wavelength for the output spectrum.
In part B of this lab, we measured the divergence of an LED and a laser diode. For the LED, we mounted it in a rotation stage pointing 90 degrees away from our photodiode. We drove the LED with a 100 Hz signal and recorded the peak-to-peak voltage for angles from -90 to 90 degrees. This gave us a fairly good Lambertian distribution. This was repeated for the laser diode, but driven at 1000 Hz, and two different measurements were taken, one with the junction perpendicular to the direction of rotation and one with it parallel. Finally, we measured the polarization ratios of the LED and laser diode. A linear polarizer was inserted between the diode and photodiode and rotated to find a maximum and minimum reading. Dividing the max by the min provides the polarization ratio. For the laser, we found a ratio of 136, and for the LED, 1.07. In part C, we used an integrating sphere to measure the output power of a laser diode and an LED against drive current. The LED was placed in line with a multimeter to measure the drive current, and a dark cloth was placed around the setup to minimize stray light. We then varied the drive current from 0 to 80 milliamps, recording the power in microwatts. You can see a linear increase until 20 milliamps, then a gradual plateau. We then replaced the LED with the laser diode, ranging the drive current from 0 to 40 milliamps. This time, there is a clear threshold where extremely little light is released before reaching. Once the threshold is reached, a nearly linear relationship is observed.